Good morning. We're looking at example 6 out of section 6.4 optimization best fit curves out of business calculus with Excel. Once again, we're going to look at an example where we have a model that isn't one of the 6 models that's used for the trend line, and we'd like to fit a curve. This time we're going to use the logistic model. Things constrained growth like trees will do that. So I have capacity. The amount that I'll have is capacity divided by 1 plus c to the e times e to the minus rate times time. Someone has given me time and trees, and I'd like to predict how this works out. So the setup is pretty much the same as what we've been doing. I just have a different model here this time. If I look at my formulas, we'll see that I've simply taken capacity C and rate and plugged them into the equation that gave me my model. That gave me a predicted value for the amount of trees. I look at the difference between the two, square it, add them up. That'll be the sum of squares error. I'd like to minimize that. And so I'm going to do it by finding the minimum using solver. I'm going to go back and unshow the formulas. I want to go to data. I'm going to use solver. Solver has been set up. I would like to minimize the sum of squared errors by changing capacity C and rate. I give 3 initial values to start with and turn solver on, and it settles down that my capacity is about 15,000. My initial starting point, I'm going to look at that and say C is 99 there, 100. That means I start at about 150, and my rate is the exponential that it would grow out if it was unconstrained. So this has found a solution that's the best fitting curve. Notice it's really a pretty good solution. The sum of squared errors is 17, where it was in the hundreds of millions before.